Hi, and welcome to our talk. We're going to talk about less compliant than the sum of its parts, how open source can bite you. And this is not meant to be fear mongering. We're going to be talking about how you can benefit from the use of open source securely. So I'm Taylor Smith, and I'm a senior product marketer here at Prisma Cloud, and I'm here with Ashley Ward. Ashley?
Hello all, thanks for having me along. My name is Ashley Ward, and I'm Technical Director in the Office of the CTO.
Great. So today, applications are more assembled than built. So if you've ever been on an assembly line or seen videos of assembly lines for modern cars, you'll probably have heard that most of the parts are not built by the company building the car. So if you're at GM or over in the UK, if you're at Rolls-Royce, because I know Ashley's a very fancy man, so he drives his Rolls. The parts are not built by GM or Rolls. They're built by subcontractors or other smaller companies. And then GM takes those different parts and assembles them together. In modern software development, that's true as well. So Forrester did this study, and they found that 70% of most code bases, so 99% of code bases had some open source component. Of those, 70% of the code base was open source. And that's way up from 2015 when it was only 36%. So it's more taking off the shelf all these open source components, assembling them into an application that's maybe a CRM or an Instagram, and actually building out, an application that's built on open source, which is great. The reason why people are doing that is because it's easier, it's faster, it's safer, and it's extensible than when you build from open source. You don't have to reinvent the wheel. You get a head start based on existing code. It's been vetted by the community. We're going to touch on that one. And then it's extensible. The code is open to the public. So even if it doesn't fit your need perfectly, you can still change it, modify it, and use it to your needs. And Ashley's going to talk about some of what makes up open source.
I am indeed. Thank you very much, Taylor. The thing with open source, if I can get my screen shared out, was Taylor still sharing? The thing with open source software is it's not meant to be fear-mongering, exactly as Taylor says. We're not saying here are all the problems, don't ever use open source, because that's counterintuitive. It's not actually going to work. What we're saying instead is what actually makes up open source software. So what are we expecting when we get something? So if you think back to that picture with all the parts for the car, it's a similar kind of thing. So we've got, we can have a Git repo that's sitting there, and inside there, I'll describe the bits that make up my application. And in those bits, I might say I've got a list of what's required, and then the package manager for the application, it'll then go, oh, I need all these dependencies, and build all of those together. And so you actually end up saying, I want this either specific version of software to be installed, or more usually, you would say something like, I want this version or newer. And that's where different languages have different ways of putting these things together to make sure that they're all, it's the exact same, whoever builds it. But you can have things like a semantic versioning is what you would use to say, I want this version or something newer, perhaps. And you might have things like a package-lock file, which says, well, when we built this bit of software, these are the bits that we used, and these are the versions that they were at the time. And this is all great, but it does mean that you have a whole list of different dependencies that will be in there. And each one of those, because it's active software and it's part of that open source community, is going to be getting updated. It's going to be frequently updated in a lot of cases. And that's really, really great, except from our security side of things. Now, Gartner estimates that over 70% of applications contain flaws stemming from open source components. I'd argue that's simply because things aren't being updated by whoever's using them, as opposed to there being a fault with the open source software, because it's easy to take 1 + 1 and get a different result than 2. So 80%, the problem is 80% of public exploits are published before the CVEs are published. And on average, the exploit is published 23 days before the CVE is published. Now, that's from our threat research department. That's Unit 42 from Palo Alto Networks. And that's quite scary, actually, to think that the exploit's out before we've got that CVE, which is going to drive the patching. And bear in mind that this was problematic enough when we were managing an operating system with, 100 packages or so. But when we're actually looking at applications that are running in there and they themselves have all these different open source components, then that's a much greater overhead. And sadly, the reality is this is what patching really looks like in a lot of cases. And that's simply because once the patch is available, and even if we're going to say, let's say there's no exploit until after the patch is created. Let's be in a nice, happy place. There's still a huge amount of time between when the patch is released and when an organization gets to patch it. Now, it wasn't that long ago, it's not ancient history, but Equifax back in 2017, they were using a version of struts that was 2 months old, and that's what the problem was. But even if we're not having people doing, really complicated exploits, there are other problems with having a code base that's open source. And the problems are things that we can overcome. So again, it's not me trying to scare people and say open source is bad, far from it, but we need to go in with our eyes open. A favorite of mine is the Node.js event stream module, which was taken over by a bad actor, as we would say. And I'm going to look at my notes here for the quote, because what happened was the developer who owned that module somebody reached out and said, can I start maintaining it? And the developer said, he emailed me and said he wanted to maintain the module. So I gave it to him. I don't get anything from maintaining this module, and I don't even use it anymore and haven't for years. And that's the thing. That was a very simple social engineering exercise to take over a popular module. And the social engineering was, can I have this, please? And yes, you can. So, the second problem we have is managing the licenses. There are a myriad of different licenses that are out there, and we see in the news they're changing all the time, which ones people are using. Germany has tested in court the validity of open source licensing and found them to be good. So now many organizations really need to have a look and say, well, what are we actually using and what licenses are we willing to accept in? And there are various different things that crop up here, whether they're copyleft, whether they're you've got to attribute if you use them, whether you can use them at all in proprietary software. There are a myriad of different things there. So I'll hand over to Taylor now.
Yeah, thanks. So this is just one example. If we look at a modern application, you can see there are all these different licenses and just this one single node service. And this is just page 1 of 83. Going through all those licenses, keeping it all together, keeping track of the different meanings of the different licenses, that's really challenging. And it's something that shouldn't be a part of a developer's day job. Similarly, if we look at what an exploit might look like, some of them are super simple. So I just want to go into one of these, the HTTP lib2 Python extension. Basically, all you had to do if you had an outdated version of HTTP lib is include in your header this simple /xa0 over and over and over again. It would spike the CPU and take down the service. It would just completely denial of service the service that you're running. So these attacks are not necessarily super complicated either. One of the solutions out there is to do software composition analysis, which inventories your open source packages in use and adds in the vulnerabilities and licenses for each of those packages. And this way you have a complete view of the packages in your environment for what you're developing, or if you're in the security perspective across your environment. So you kind of know your exposure. And the idea is to have this as full life cycle as possible. So as early as the development local environment that the developer is working on, give that feedback about the vulnerabilities they've introduced with a recent package they've added. So if they're running an import function in Python, give them the feedback that, hey, this package is vulnerable, or it violates our license compliance. And then going through all the way through to the repository, blocking container images from reaching the registry that have vulnerabilities that are maybe critical or high, depending on your levels of severity needs. And then blocking in production, blocking any build that includes vulnerabilities or license compliance issues. So you have that full life cycle, and throughout the whole thing, giving that feedback back to developers. That way you're maximizing the amount of time they have to make fix changes and giving that visibility to your security and compliance teams. And the benefits are clear. You get to identify and update and remove vulnerable components, which is much more likely to happen if the developer gets that feedback in their IDE and early on. And then you can reduce the risk of violating open source licenses. So a developer no longer reaches that point where, hey, I've come too far. I'm going to push this into prod, even though I know I violated. I've added in a GPL licensed package, which I shouldn't have. And then there are no surprises at any stage. So giving that consistent feedback at each stage, so a developer doesn't say, "Oh, I'm good. I just committed my code to the registry. It ran through the CI, no problems," and then it gets pushed to the prod and gets a red flag to them about a new vulnerability they didn't know about. Of course, some of that's not possible to avoid as new vulnerabilities are coming out daily, but giving them as much as possible consistent feedback.
Yeah, that's the crucial part, isn't it, Taylor? I mean, that's where being able to say, if I'm in a DevOps team and I'm operating at pace in order to deliver all the different things that I've got to deliver, yes, there's obviously a part that says I should be aware of all the different licenses that I'm using, but ultimately that's very difficult to put into practice in reality. Let me get my screen shared out there. Yes, we've got demo there, so we're going to hope the demo gods are going to be kind to me. The whole point of this is that we're saying here is the information early, whether it's licensing, whether it's vulnerabilities, about saying using the tools that the developers themselves or the DevOps teams are using and saying, okay, if you're using an IDE, that's great. If that's the earliest that I can fit security into the life cycle, then let's do that. If it's going to be somewhere in a Git repo, for example, and I do have the demo for that as well, but believe me, it looks pretty mucky all in a command line interface, but we could be scanning something there as soon as somebody wants to do something in a repository. Here, I've got some pretty colors, so of course that always comes over better in a demo situation. But here I'm saying, all right, well, what about in my CI tooling? So if if we look at why would we be using the open source software to begin with? Well, because of all those great reasons that Taylor gave us. When we're building a car, we're not trying to reinvent the wheel or reinvent the door handle. In fact, there's probably somebody who can build pretty good door handles. So we just want to make sure that stylistically that's okay. And that's the differentiator for my car company. In the same way that for an organization out there, the differentiator isn't how secure it is. That could be a brand or a risk problem in the future, but actually the software itself and what we're building. And so here I'm going to say, right, let's look at what we're going to and how we're going to integrate into a build cycle. So I'll jump over to the rules just to try and give you an idea of what rules would look like. So I'm going to say that when I'm building an image, and yes, this could have been, and you would put this in place, whether it's a code repo, whether you're building functions as a service, whatever it is you're doing, I'm doing it here to show the art of the possible. You can then say, well, let's have automated rules that then my DevOps teams can consume, almost like security as a service, that they can consume these things. We've got policy now as code. We don't need to worry that Ashley in his DevOps team needs to try and figure out whether this medium vulnerability is okay or whether this medium vulnerability is not okay, because we can put rules in place. Now, we want to, and I'll talk about it a little bit more in a moment or two, we want to encourage collaboration between our different areas in an organization. But we can still put those guardrails in place. We can say, look, as a general rule, we don't allow critical things to come through. In our CI tooling, we're going to warn everybody, in fact, of everything that's medium and above, but we're going to fail builds if there's something critical in there. Now, of course, then you want to be able to handle those edge cases that will come up about, well, what happens if a particular CVE is in? Or perhaps you want to make sure that you have grace periods. These are all things that when you're looking at how to integrate this into your pipeline, you're wanting to say, right, what did we talk about? What did Ashley tell us before? As early as possible in the IDE, in repos, to be scanning those repos, when we're building images in CI/CD, and of course, Taylor mentioned when we're pushing things into the runtime and the runtime itself. And those areas, once you've identified those, then you're saying, what is it that I want to protect at each stage? And in fact, Taylor had a great slide there where he had some things had guardrails and other things did not. And so then we can put those controls in place and bear in mind that you will have to have some form of exemption strategy as well. In this case, I've previously run this build. I didn't trust the demo gods for this short demo, but this is where we can say, look, we didn't have any rules in this case, and everything was green and went through. But actually, in this case here, we had that failure. And just before I go back to taking everybody through some slides, remember, we want to communicate. We need to be able to say what that meant. So not only does that appear and the record of that appear in Jenkins for my DevOps teams, but also here in my security software. So however you're going to be feeding that back, it needs to come through to say that, yes, this was a success, or no, this was a failure. Okay, let's jump back over to some slides and see what else we've got to say, because to me, the most important part is around the collaboration. We all too frequently jump into tooling, and that's what I've just done to show you the tooling and what's available there. But actually, what is it that we're trying to do? So DevOps is really not just the mashing together of dev and ops. And as a recovering operations guy, I was a Unix admin back in the day. As a recovering ops guy, I can say that it was quite a push together, but that's DevOps light. Patrick Dubois talked about this. He was one of the people who coined the DevOps movement. And actually, true DevOps is the whole organization working in an agile way to accomplish a common goal. And so I'd say that actually we should see this growth happening, collaboration between engineering, security, and legal coming in. So whether that will become DevSec, audit, legal, ops in the future, I think maybe that's a bit of a mouthful. But if it does, then you heard it here first. But actually, that's what it's about, because as we see licensing now becoming a feature and something we need to worry about, we do want legal there. And we want to be able to consume those policies in the same way as I talked you through for vulnerabilities. We want to do the same thing for those legal policies. What are the compliance requirements that I have? What are the different licenses that I can or can't use? Where are those hard lines to stop? And so when you're going to be implementing this and trying to bring everybody on board, then I can say that there are some really useful things to look at for software composition analysis. We want to show that improvement. When you first start analyzing your software and what makes it up, you will probably get a fright. And that's not because the software is bad. And that's the crucial thing. It's not because what we've got is fundamentally wrong. It's because we didn't have visibility into these things before, or the governance and guidelines to help deal with it. So show that improvement, show the continual improvement of what we're doing, whether that's by having a burn down chart, if you're doing things with burn down charts, whether that's held by a DevOps team or security hold this and are constantly analyzing, you need to show that light that's there at the end of the tunnel. The next thing is surface the key issues that come up. So if you are looking at, well, I've just got a sea of vulnerabilities. Well, what does that actually mean? Do you tackle them by which are the oldest, perhaps which are the highest attack vector, or what ones are actually achievable? Perhaps there's no fix out there just now, or perhaps the licensing is your bigger concern. And so have a look at prioritizing the issues and really drop that risk down. Don't look at it as everything is the same value, because they have different things. A caching service that's not exposed to the internet is a much different beast to one that's sitting in your DMZ. And then that last one there, I would say, is very crucial. Guardrails, we're not putting just these gates. Somebody once described it to me as let's have speed cameras and not speed bumps. We want to be able to say yes to things more often than we have in the past. And if you'd like to learn more about how we solve these problems, then come along to our Spotlight session, why full stack, full lifecycle security is essential to cloud native security. I hope that we'll see you there. Thank you.
All right. Well, that was an amazing session. Thank you so much. And thanks to Ashley as well. All right. So we did have some awesome questions come in. This, I think, is a very important one that you touched on a little bit during the presentation. How do we prevent OSS code base from being sold or given, as the case may be, to unknown or even known bad actors by folks who either no longer care or aren't able to care? Maybe they move on from the organization and they're not, able to maintain.
Yeah, it's a good question. So obviously we can't prevent that. We don't own the open source, and somebody can just hand over a repo at any time they want. But what you can do is just keep an eye out for things that are introduced vulnerabilities. And once that happens, once it's every package version after the one you're using is vulnerable, then it's time. You got to know it's time to move on to another package, or to basically find an alternative. And I want to preface this by saying it's very uncommon for that to happen. Luckily, I'm a huge proponent of open source, and luckily this type of situation, while it's kind of fun to talk about the examples like the Chrome one you mentioned, and the one that Ashley mentioned where the gentleman just handed it over, it's pretty rare. So it's pretty safe to assume you can trust open source, and you can use open source packages.
Yeah. It's one thing I think that's constantly coming up too is that, and I think this ties back to like security awareness training too. Like what was lax in in Ashley's example of the person who was just like, oh sure, yeah, go ahead, take it. Did they check that person out? Were they a little bit suspicious? So maybe there needs to be a little additional training going on, at least for that person.
Yeah.
Yeah. All right. So following on from that though, what do I do if I identify a vulnerability in an open source package that I'm using or going to use?
Yeah, so this is another very good question. The idea here is to try and upgrade as much as possible to the latest version. But obviously that's not always doable because they're breaking changes, especially once you get to major version numbers. Open source providers usually do a good job of making sure the subversion, so anything like 0.3 to 0.4, isn't a breaking change. So it's good to test things, make sure it doesn't break. But if you can move up to major version numbers, it's always more secure. So Python 3 is more secure than Python 2. So the idea is move up as possible. And there are tools out there like the ones we provide where they can tell you what's the minimum that you need to get to in order to be secure. So you don't have to worry about as many breaking changes, because we'll say you only need to bump it up by a 0.1 bump release. But obviously, if you can make that jump all the way up to a major release, it will be more secure.
Okay. All right. What is the difference between compliance in, say, an open source context versus like proprietary software licensing?
Yeah. So I think one of the things that make the big difference is you're not going to run into things like copyleft in proprietary licensing. So one, you'll have more people to work directly with. So if you're in the open source world, you're going to have to basically depend on what is this license and get a good understanding for what does it mean to have that license, or at least have a legal team that tells you what's good or bad. So can I use this package with this license? With proprietary software, it's a little more cut and dry, because it's all a matter of have we negotiated the right license with the company we're working with. But once you've decided that, oh, this open source license is okay to use, then at least then it's a lot easier to just grab packages as long as they fit that license compliance. And so you can just use any open source package that includes that.
Awesome. All right, folks. Well, I think that is about all we've got time for today. I want to thank you so much, Taylor, for answering those questions. And thank you so much to the audience for joining us. We are just about at that time where we draw our, oh, here comes another question. So I'm just going to cut myself off and go back and grab that here. And just give me a second here while I scan through this. Just in the news, Threat Hunter found the 0-day in Apple code and did not report to Apple for over 3 months. So in this case, what do you do in a situation like that where someone identifies a vulnerability and then just does not let the vendor know or doesn't let the maintainers know? Is the solution more regulation? Are you kind of stuck with a trust situation? What are your thoughts on that?
Yeah, so this is more that question about proprietary packages and proprietary software. What we run into a lot, what we're discussing is more the open source components, which of course there are going to be 0 days out there that people don't inform other people about. They're not reported to the open source owner, and in this case, Microsoft not reporting it to Apple. The best protection then, that's why we recommend full lifecycle protection. So it's good to scan your open source licenses and proprietary packages for vulnerabilities, make sure you patch them. But then you also need to have that runtime protection. So you can block things like malicious files being uploaded or malicious processes being spun up, or network, if you notice lateral movement, locking things down so only specific services can talk to each other, and you notice things like port scanning. So you can identify all the pieces of 0 days, because there's a lot of common patterns no matter how it's exploited. Even if it's fileless, never been seen before, there are other ways to lock it down so you can still protect against it.
Yeah. Great. All right, folks. So sorry, here, where was I? Okay. Amazon gift card winners. That's where I was. All right. Today's Amazon gift card winners are Andrew S. is our first gift card winner. Congratulations, Andrew. Bianca P. is our next Amazon gift card winner. Congratulations to you. Our third winner today is Gerald W. Congratulations, Gerald. And our fourth winner today is Joe G. Congratulations to all our Amazon gift card winners. We will be sending an email to you with instructions for how to claim your gift card. So keep an eye on your inbox. If you don't see it there, please make sure and check your spam folders.
Congrats.
All right, folks. Yeah. Well, thank you so much again for your time. And thanks again, Taylor. We hope to see all of you again at another Security Boulevard webinar. I am Sharon Florentine signing off.
Thanks, Sharon.
Thank you.